Okay, hello everybody. Today I'm going to talk about indicators of sustainability and methodologies to assess resiliency. And the first thing that we need to address is that we need to make the conversion or the transition towards a more diversified system, given that most of the emissions are produced by industrial agriculture, monocultures, or agriculture that use a lot of external inputs. For that reason, we need to make this conversion. And most of the challenges that farmers, extensionists, and researchers are facing are to know when the ecosystem is healthy and to know the health status of the ecosystem after initiated the agroecological conversion process. And for that reason, it's very important to emphasize on the agroecological principles that underline the productivity, the sustainability, and the viability of the ecosystems. The indicators are spatial and temporal genetic and species diversity at farm and land scale level, crop and animal integration, biological activity on soils and biomass recycling rates, and optimization of the use of space that needs to relate to the agroecological design. For that reason, I think it's very important to think about different indicators that are associated, for example, with the principle of nutrient and biomass recycling. What are the practices that farmers are using regarding these nutrient and biomass recycling? Or the principle of biologically active soils. So it could be associated with the amount of microbial activity or presence of earthworms and things like that nature. So we need to think about what kind of indicators we need to emphasize and to see if the principle of biologically active soils are present or not. In terms of soil biology, what kind of macro, meso, and microfauna we can find in the system, and also what kind of the amount of accumulation of organic matter in the soil, or if we don't have any organic matter in the soil. So this could be one important indicator to have in consideration. The other principle is associated with the diversity. So we can think about species diversity, the different kind of crops that farmers have in a specific territory, or the principle of genetic diversity that's so important, where how many varieties they are using, how many native species they are using, and so on. And if they have animals, this one could be a very important in terms of the crops and animal integration, what kind of relationships have the animals with the crops. And the most important one is the functional biodiversity. It means the key biodiversity that are necessary to be present to allow the different ecosystem services. In this case, for example, we talk about the parasitoids and the predators that are very important in the biological control of insect pests, but also the composers that are very important in the nutrient cycling principle. And the last principle is about landscape matrix. So we need to think about if the system, the agroecosystem, is surrounded by just big monocultures, or they have a very diversified matrix that helps to keep the local cycles of water when we are talking about climate change resiliency. And this methodology of indicators needs to be done with farmers. We need to discuss what kind of indicators are more relevant to farmers and try to evaluate these indicators at the farm level. In order to choose what kind of indicators we need to use, we need to have in consideration that those indicators need to be relatively accurate and easy to interpret. need to be sensitive in order to reflect environmental changes and the impact of practices on the soil and in the crop health. Need to be able to integrate physical, chemical, and biological properties of the soil, and need to be easy to relate with processes of the ecosystem. For example, we need to understand the relationship between vegetational diversity and insect and disease population stability, because functional biodiversity sometimes need, for example, predators and parasitoids need pollen and nectar to for the reproduction and fecundity. And if we have this vegetational diversity, we are going to provide the elements for this functional biodiversity to thrive. So the evaluation, as I said before, needs to be done with farmers and try to understand what do we want with different methodologies. So I'm going to explain here a methodology that is very simple. We call rapid evaluation of soil quality and crop health, because in agroecology we work with these two principles of soil quality and crop health, very important. And the goal of these evaluations is to estimate the health of the agroecosystem using very simple indicators in order to measure the crop health and the soil quality in the field. And this methodology also allows to visualize in an easy way the state of the soil and the health within the farm, in different parts of the farm. And also this methodology allows to compare different systems or evaluate the same system through time. And as I said before, this is how we work in agroecology. You have in consideration the principle that I mentioned before, the agroecological principles. And with these principles, you design your agroecosystem, and the design of this agroecosystem is based on this, and the use of biodiversity below ground and above ground. And the biodiversity below ground has to, it relates with the habitat management and the biota activation and diversification, and the accumulation of organic matter that enhance the nutrient cycling and nutrient management. And the biodiversity above ground have different practices how we can use diversity. For example, in terms of the habitat management, you can use different strategies of plant diversification and enhancement, and the idea is to enhance the functional biodiversity, in this case, beneficial fauna. With these two pillars, we guarantee that we can have a good crop health and the agro-ecosystem health. The methodology of the rapid evaluation of soil quality and crop health have different protocols. Very easy. I wanted to explain that we need to define the indicators that are relevant to farmers, and then we can give values from 1 to 10 to particular indicators, being 1 the less desirable value, 5 is like the threshold, and 10 will be the most desirable value, according with the characteristics that we give to the soil crop, given certain attributes to observe for each indicator. Once you give the values to each indicator, we compute the average for soil quality and crop health, and the farms that have average values of soil quality or crop health under 5 are considered under the sustainability threshold. So we need to see what are the weak points and then improve the practices, agroecological practices, in order to achieve the sustainability. And then we represent these indicators in a very simple graph called amoeba in order to have visual comparison. And here, for example, we are in a vineyard in Northern California working with farm workers, training them in different indicators, and it is possible to do this evaluation in 4 or 3 hours that we are in the field. And as you can see, we have selected different, especially this list of indicators we developed in grape system, and you can see that indicators of soil quality, we select structure, compaction, soil depth, status of residues, color, odor of organic matter, water retention, soil cover, erosion, the presence of invertebrates, and the microbial activity. And for each indicator, we gave values for 1, 5, or 10, and also we have a specific characteristic for what is 1, what is 5, and what is 10. The idea is that the farmers look for the indicator, read the characteristic, and give a value that could be from 1 to 10. And these established values just help the farmers to evaluate their own indicators. For example, in this case, we want to evaluate the structure, because as you can see, the texture we cannot change with practices, but the structure we can change on time using different agroecological practices. So we want to evaluate if these practices are enhancing the structure. And another way to see this one is try to see what are the aggregates that the soil has when you compare a soil from the forest or the cultivated soil and put it in a yard for 24 hours, and you can see what soil had more structure and more aggregates. In terms of erosion, we can, because this is a very rapid evaluation, so we can evaluate, for example, signs of erosion, like for example, if we have gullies or different rock that are exposed, and we can give values of the erosion that we have. In this particular case, the evaluation are inverse. So you put the value of 10 means that there is a high level of erosion. You put values, if you put values of 10 means that you have less erosion than you get values of 1 or 2 or 3. And the same with compaction. So this is one way, using a wire and try to see, you can find the hard pan, the resistance that you can get with the wire. This is one simple way how you can evaluate compaction. And another indicator that is very important is the percentage of soil cover with plants that are alive or dead plants, but the idea is that the soil needs to be 100% covered. It means that the value will be 10. If not, you give value or the percentage. And the roots development, it's very important because these indicators can be associated with the compaction. You find a root that have certain kind of development, for example, the one that Miguel is pointing, it means that there is a hard pan, so it's associated with the compaction. And soil microorganism, one way that we can do is evaluating, for example, the rhizobium. In this particular case, the associated with the relationship that the rhizobium have with legumes, and evaluate if these rhizobium, for example, are active. One way to do it is just cutting the nodule and see if they are with the reddish nodule. It means that they are active. Another way, it could be using water peroxide. Color, odor of organic matter is one of the indicators that many farmers in many parts of the world are using. This is a very qualitative indicator, but it's so important in the case of the soil quality. The presence of invertebrates, we can evaluate different kind of invertebrates like collembola or millipedes, or even earthworms that are so important. The channels of the tunnels that the earthworms make, and this is one way how we can, if we have a lot of these soil biota, it means that the activity are very high. And also in the field, we can weigh the amount of earthworms. So there are plenty of methodologies, and also we can provide some information how to evaluate the macrofauna. It's more easy than the micro. And as I said, the microbial activity is so difficult to see. It's one way that we are using with the small farmers, at least in Latin America, is using water peroxide that you apply to the soil, and you can see the effervescence. It means that there is a lot of respiration because it's the reaction that the water peroxide made with the carbon, the respiration. And this is one indicator of if the soil is alive or not. You can compare, you have different samples of soil from the forest, or a conventional soil, and organic soil, and you can see the difference in effervescences and also the temperature. And another, in terms of crop health, we can use indicators like disease and pest incidence. So sample some plants in the field and see if there is a presence of disease or damage of insect pests. And also you can evaluate or account for the number of predators that you see, the composer or parasitoids in terms of the functional biodiversity. The appearance of the plant is so important. It's a good indicator also of crop health, and also the crop diversity that you have in your farm. And then you place all this information in a graph that is very simple. In this particular case, in Colombia, the farmers don't have computers, so they do this by hand. But in other cases, they evaluate in, for example, in this case with Amoeba, that is a graph that you can find in Excel. And here, for example, we are comparing two different systems, the traditional that small farmers are using compared with the conventional farms. Each point are the different kind of indicator that we were using, and you can see that the traditional farms have better indicators or high value of the indicators in certain points, and in others they have a weak point. So this is like a radiography that you can perceive in what point you need to intervene. And this is an exercise that you can do in your farm. This is particular example from Japan, but we evaluate different indicators in terms of plant health. We evaluated the landscape diversity, the crop species diversity, the genetic diversity, the animal integration, different indicators of soil quality, and different indicators of plant health. And they gave values 1 to 5. It's up to you. You want to give value 1 to 10 or 1 to 5. And also we integrate other indicators that are more that were more important for those farmers in Japan. For example, the level of self-sufficiency, the energy sovereignty, the labor intensity, market linkages, family involvement, and land tenure. And so as I just wanted to bring this example because you can see that the indicators can change. The idea is to use the same methodology to evaluate whatever you want to do. In this particular case, we were comparing an urban farm with a rural farm. And you can see here that the urban farm had very low value in landscape diversity and energy sovereignty. And the NAMI's farm have much better values, but in both, they don't have animal integration, they are very weak. So these are points that you can see in order to intervene and to enhance that particular practice. And here is an example that is in Spanish, I'm sorry, but you can see that we can compare indicators of soil quality and plant health. In this particular example, we are comparing organic farm with transition farm that is in transition. This is in coffee production. And then once we have all the indicators of soil quality, you give the value. You can see that the values of organic farms and farms are higher than the transition farm. And then you take the average, and in the soil quality, average is 9.5 in the organic farm and 5.8 in the transition, compared with the soil plant health that the organic farms have 7.5 versus the transition farm 4.2. And then if you have, like, you are working with 10 farmers, you can even compare those farmers do the exercise of evaluating the soil quality and plant health. And you can see that two of those farmers that were part of this process have better average on soil quality, and this is what we call them lighthouses. So those farmers, the other farmers want to know what those particular farmers are doing in order to have high value of soil quality. And another principle that's so important and is the innovation, the satisfaction, and the self-confidence that farmers have. For that reason, you can develop certain kind of indicators that are important. This methodology helps us to redesign the agro-ecosystem, enhance different practices, and see if we are advancing in the objectives and the goals that we have in your farms. And another way is to evaluate. This is the previous information that I gave was about the farm. And then you need to see what is your landscape matrix. So you can evaluate if you are, what percentage of vegetation, natural vegetation you have around your farm. And you can give values 1 to 10 according to this methodology. So in this first part, I really wanted to present this simple methodology, how to assess the sustainability, especially thinking on the process of the transition or the conversion from conventional high input agriculture into more agroecological approach. Why? Because as we discussed in the first class, industrial agriculture discusses most of the emissions that are creating the problem of climate change. And if we understand the root causes of the climate change that is industrial agriculture, I think this is an opportunity to move this industrial agriculture into agroecological approach. And also during this transition, we need to evaluate to see if the system is achieving the sustainability that we want. In the second part of my talk, I want to talk about the methodologies, how to assess resiliency. And the definition of resiliency is the propensity of a system to maintain its organizational structure and productivity after perturbation. This perturbation or shock can consist of different kind of frequent stressful event or unpredictable event. Resiliency exhibits two properties: the resistance to the shock and the capacity to recover after the shock. This is the most important thing. And for that reason, we think that a resilient ecosystem is able to still produce food after suffering the events of a storm, of hurricane, or drought, or even if another event like increasing the cost of petroleum or external input scarcity. But the resilience is the capacity of the resist the shock, but also the recover after the shock. It's very important, as I presented last time, to increase diversity in order to achieve resiliency. So we think that agricultural diversification can enhance the resiliency of the ecosystem and protect the production capacity in various ways. One is protection of crops against extreme weather effects and fluctuation in temperature and precipitation. And if we manage the system with agroecological approach, we can see the advantages that especially when you have more vegetational complexity, this diversity are linked to the resilient capacity of the system to climate change. There are certain kind of principles that we need to have in consideration in terms of resiliency. One is the diversity, the heterogeneity, the autonomy, the redundancy, the collaboration, the flexibility, and the regeneration. As I mentioned before with the example that I presented last time, we have an extreme climatic event. We need to see if the farming system have the resiliency, and this farming system resiliency is associated with 3 different levels: the vegetational complexity at the landscape level, the surrounding landscape heterogeneity, and the soil and water management at the landscape level. And at the farm level, we can see if we have soil organic matter enhancement, or if we have diversified fields in the borders, and soil cover at the farm level, water conservation, harvesting, crop rotation, polyculture, agroforestry, different arrangement that you have in the design. So there are simple methods to assess vulnerability. In this particular group that I work with, Red Agres, we have developed a methodology to work with the traffic light. And this particular example is in Central America after different hurricanes that they had suffering. And we use the traffic light to evaluate the vulnerability. And you can see the color green means low vulnerability or hard resiliency. And in this particular case, the idea is to see what action are we going to take. And green, the values are given 1 to 5. So low vulnerability value means 5. Yellow is medium vulnerability, and red, high vulnerability. The idea is to see what happens if the farms are stayed in red. We have high risk to damage. What happens if we are in yellow, or how we do the transition from red to yellow, and how to do the transition from yellow to green. The idea is how we move ahead to redesign the farm in order to be more resilient. And in this case that I wanted to explain is as I said, in 3 countries in Central America, and this particular one in Costa Rica, where Nicaragua and Honduras, where farmers were deciding what kind of indicators were relevant to the cocoa plantations. And you can see here that we develop with farmers different kind of indicators. For example, the landscape diversity, the orientation of the slope, the structure, the diversity, the different conservation practices of soil, and so on. And then the farmers just need to see if they have, what are the state that they have in their farm. And I'm sorry that these are in Spanish, but you can see that the idea is that each color has certain kind of characteristics that help farmers to see what situation they are placed. And you can see that they just need to put an X if they have high slope, or if they have a low landscape diversity, and so on. And then in this particular one, we were comparing 2 different farms, a farm that were very diversified with a multi-strata agroforestry system compared with another farm that only have banana and cacao. And you can see that the indicators are in each of the points of the amoeba or the radar. And as you can see, the diversified agroforestry system have better indicators, the one in blue, compared with the simple agroforestry system that have values very low in slope and exposure. And this is another example from Cuba, what they were exposed to hurricanes. So in this particular case, at the center, the means that they know the practice and have full access to implement. And the second circle means that they know the practice and the access depend on the external sources of the community of the farm. And the third cycle, that is the green, they know that the practice exists and the access or implementation depend or integrating management of external internal factors. And the fourth cycle is very difficult or impossible to manage or implement in the practice. So the most important thing is at the center, the practice is that they know the practice and they know how to implement. And the same with the resistant to droughts in this particular case. And also post-hurricane recovery, there are different questions that you can ask this is a particular research that one of my students did in Cuba. And I think the one important aspect of the resiliency is the social resiliency. And this particular case is we wanted to evaluate the social networks um, to um, to know if they can account in order to be more resilient to these particular events. So, for example, if a climatic event happen, and here particularly they are asking for 3 people in the community that they can ask for help in order to restore or recover their farm. And also, if they have a problem in the family, they ask to mention different people that they ask for help. So you can see the social networks that are so important in this particular case. And the last methodology that I wanted to mention is to evaluate the risk. And the risk is given by the vulnerability and reactive capacity. And for that reason, you can see that in this particular methodology, we are evaluating the damage level. And if we have a climatic event, and the threat is the frequency, intensity, and duration, but in a region, this particular event are going to affect the region in particular. And so we try to use this one as a constant. For that reason, we think that it's very important to have in consideration the vulnerability and response capacity. And here we are developing 3 different indicators that evaluate vulnerability and different indicators that are going to evaluate the response capacity or reactive capacity. So here is the formula: threat that is constant equal to vulnerability over reactive capacity and recovery. And this particular example was done in Colombia, in my hometown of Antioquia. And with one of my students, we identified different farms, in this particular case, agroecological farms, small farmers, comparing with the different conventional farms in the same region and the same economic conditions. And we evaluate different indicators of physical vulnerability. Those indicators, as you can see, are slope, diversity, the landscape diversity, soil and erosion susceptibility. And for these 3 big indicators, we have different sub-indicators: slope, diversity of landscape, infiltration, soil structure, compactation, and different signs of erosion. And if you see just the colors, you can see in the conventional farms compared with the agroecological farms, the agroecological farms have more green and yellow colors compared with the conventional farm in terms of vulnerability. And the same with response capacity. The conventional farms have more red and yellow compared with the agroecological management. And you can see that we have different kind of indicators of response capacity. And then, as similar to the other methodology, we try to compare farms, agroecological farm with conventional farm, and you can see that we post all the indicators, and you can see that the conventional farms have less soil cover, less or values of the indicator very low in living barriers or in water management, soil organic matter, and compared with the agroecological farms. So the idea is to observe these weak points and then try to enhance the practice in order to, in the next evaluation, they can have better values. And once we have the indicators of response capacity, we apply the formula, and then we make the risk assessment and get the index, the risk index, and then we use this risk triangle to place the farms that have very low risk with the light yellow compared with the very high risk that the farms that have value higher than 4 or lower than 1 are the farms that have very low risk. And this is another example to evaluate risk assessment in coffee production with another student of mine here in Colombia. And we this is in coffee, and we have two threats. When you have discussion with farmers, we think that the major threats is, for example, the drought, but it's not. In this particular case, they thought that they have two big threats, like the drought, but also the prices of the price that they receive for the coffee. And so, just to mention that the discussion with farmers is so important in order to identify what are the major threats. And then you decide what kind of indicators are you going to use in terms of vulnerability. For example, here we're very important, the productivity, the self-sufficiency in terms of food security, and also the dependency on external inputs. They wanted to evaluate this as an indicator of vulnerability, compared with the indicators of response capacity. They wanted to evaluate the shade, if they are using coffee in monoculture without shade or with shade, the soil cover, the landscape diversity, the diversity of product in the agroforestry system, the market's autonomy, the level of knowledge that they have in terms of agroecology, and the level of organization. And you can see here that just post the data in graphs with bars. You see here we're evaluating 9 different farmers, and you can see that the vulnerability were very high in 3 of them, 4 of them, compared with the response capacity that we have, like 2 that have high response capacity compared with the other ones. And here we can relate the value of the risk. If they have a lower value of the risk, it means that the resiliency is very high. Compared, if they have high value of risk index, it means that the level of resilience is very low. And same with this one. And this is the risk assessment that we want you to do in your own farms. We think that in California, the major threat is droughts, and we wanted to give values 1 to 4, and we decide, in order to do this exercise, to have different indicators associated with vulnerability, like landscape matrix, crop diversity, genetic diversity, soil quality, water use, and conservation. And for that reason, we put certain kind of characteristic, what is 4, 3, 2, 1. So the idea is that you read each characteristic and see what are the value that you think your particular farm are in terms of, in order to score your own farm. And in terms of response capacity, we developed these indicators in order for the exercise. You can change the indicator you want, but I think it's very important to at least to do the exercise. The knowledge and skills in terms of agroecology, external inputs and dependencies, social organization, institutional support, ecological services. And then we compare the mean of the mean value of vulnerability and the mean value of response capacity. And then you calculate the risk index through this formula, given the threat value 1. And then based on this value obtained in the equation, you can find the level of risk and resiliency on your farm using this table. So the risk index is 0 to 1, means that you have very low level of risk, means that you have high resiliency, or you have values of the risk index higher than 2, it means that you have very low resiliency and you need to start working. So to finish this presentation, I just wanted to say that the socio-ecological features that determine the vulnerability and react capacity of farmers to enhance resiliency of their system, and also to the community, depending on this. First of all, the external factor, in this case, is climate change. It could be climate change, it could be globalization, it could be economic factors. So we need to decide what are the major external factors that we identify. What are the threats? It could be a specific climatic event, it could be the price of the product. It could be different threats, so we need to identify. And then the threat is given by also identify what are the vulnerability, what are the characteristics of farmers and the system that determine the risk, and also the reactive capacity, the social attributes of farmers, ecological feature of the farm, and if they can recover after this climatic event. In terms of the threat, we need to identify the frequency, the intensity, and the duration. And in terms of the vulnerability, we need to identify the level of social organization, the farming knowledge and the skills, and also the collective action, the social network, and the level of agrobiodiversity when we are talking about the reactive capacity. And finally, I think this is what we are looking for with the main objectives of agroecology, and the idea to transform the agro-food systems is to achieve food sovereignty, to conserve natural resources, and to achieve the resiliency. And we think that an effective adaptation strategy evolves from the coping to adjust to climate vulnerability, and the ultimate goal is the transform. So I think it's time to think about what are the root causes of the problem, in this particular case, climate change. And if we perceive that the root causes is the monoculture, intensive agriculture system, we need to start moving and do the transition and the conversion to a more diversified farming system, in this case, with the principles of agroecology. And these are some of the books that we are produced in SOCLA. I'm sorry, they are in Spanish, but we provide some articles in English that people can start using. Thank you very much.